Hello YouTube, De-bodgery here, aka Richard Gumfaw on Facebook, not Matt Waters from EBMX. So I have my macro lens out and we're looking at the power stage, and you can see those Chinese MOSFETs up in the upper left hand corner. You can see the JMJ logo, and you can see that they're SH1001A MOSFETs. These are not import, they are not Infineons, they are not IXYS, they're not AOTs, they're not some big name brand thing. No, they are imported directly from China to China, and Chinese MOSFETs through and through. So much for all that bullshit about using high quality imported parts. Sorry guys, this is a key high value component, and once again, KO cuts corners and uses Chinese components instead. No real surprises there. Alright, you can see the two contact points for the bridges. That's what this is. It's a bridge. There's a bridge. And you can see those really small patches of solder that they make to the trace underneath. So it's about like 2 millimeters wide, about 6 millimeters long. And you can also see the entire phase bus that's here. So that's all of this right here, all the way over to there. So I can just get it on the camera. So that's the phase bus here, and as you can see, there is no copper reinforcing. There's just a little bit of added solder on top of the base copper traces. So this handling 800 phase amps, not a chance in hell. Never going to happen. Never ever going to happen. Probably even 200 phase amps is going to make this get quite warm, and you probably can't run that continuous without this getting very, very hot, in which case that's also going to cause the solder to melt and probably start lifting these bridges, which cycling from heat alone is probably going to cause the solder underneath them to break loose on these very, very small area of surface contact. And the fact that this copper bridge versus the circuit board underneath it are moving separate from each other, and the bridges are not secured in any way other than by the solder on their ends, they're going to flex and vibrate and break these solder joints. So that's going to be a failure place, a failure point, and the heat buildup right here is going to be really significant because there is nothing but the trace on the circuit board. That's it for carrying current there. And I can tell you for a fact because, well, hell, you can find 4,000 watt controllers that have more copper on them than this does. And this is supposed to be, you know, really epic power, 32 kilowatts or whatever it is. I forget what the specs were, but just stupid. Right here, these are tantalum caps. I don't know what their value is, but on Facebook, KO tried to do one of their disinformation slams on EBMX and claiming that having tantalum caps on your power stage was bad, and in fact it's very good, and here they have them too. So this is battery plus and this is battery minus, and those caps are filtering exactly what they're supposed to do across battery plus and battery minus, and you should have them. And KO in their disinformation said they were bad and that KO didn't need them and that EBMX did to take care of all the noise on their supposedly ZSX clone controller, which is complete fabrication and lies. It is in fact KO that lies, as you can see, these are JMJ MOSFETs made in China, not something name brand, not something high quality, you know, actually very low quality. Yeah. Something that I momentarily commented on in my other video about the power stage was all this white junk here. I thought it was glue, and as you can see, it's not. It's thermal paste. I thought that was glue securing the connector to the board, which would be cool, because that would be, you know, a good way to secure those in place. And in fact, that is not true. That's just thermal paste that's oozed up through a hole underneath that connector. So never mind. That's just thermal paste. It's not even glue. Let's talk about the battery minus bus here. There we go. Here's this far end of it. So, oops, there's a standoff. Sorry, I bumped the camera. Here's the copper, which is inadequate for the job. And then you got a big ass gap. that sucks. And we keep following it down, and we got a little short section here add on to the other one. Why not just make that a single piece of copper? Again, big gap to the standoff, so you don't even have a continuous current path twice. And then you got another gap on the other side, and keep going and going and going, and then you got a massive gap. This one is probably 4.5 millimeters wide. So here's the copper. This is the brass standoff that battery minus comes in from the battery pack. So that's the 6 millimeters threaded stud, and you got this big ass gap here. So really, 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 really poor current path. And then go a little bit further, and again, this is another one of the standoffs that goes up to the upper board, and you got no copper here, nothing. You just got the circuit traces. So yeah, really shoddy battery minus bus. Here is what little bit of you can see of the actual battery bus, battery plus bus on here. So this trace is here, and you can see the edge of the trace to here, up to there. So it's about 10 millimeters wide, but again, it's just standard copper thickness for circuit boards, so massively inadequate for carrying the supposed current that this controller can handle. Not even close. So right there, wherever it is, lost my place, there we go. When I do the teardown videos for the eBMX, I will show these. Oops, I bumped the camera again. That little guy right there, that is a PTC current sensor, and there is one of them on here. And it's about center-ish on the board, whereas eBMX, they have one per phase, and I'll show them to you. I already know they're there. I've already got a picture of it. I know where they are. But yeah, got one just kind of center on the board. So about all you can do is tell general temperatures of the power stage, but not if you have a hot spot or anything else in one of the phases. Whereas eBMX, they have 3 temp sensors, one per phase, so they know if a phase is overworking, something like that, in which case they can give you much better information and control themselves much better. So yeah, one PTC temp sensor is inadequate for the job, as is everything else about these controllers. So this this set of MOSFETs right here, they are a little bit closer together than the other 2 banks of MOSFETs, but they don't even have bare traces with solder added to them. They're just a skosh closer together, and again, no copper reinforcing whatsoever. And then this little bit of a bodge right here. So, you know, the phase bus comes through here, and then a day late and a dollar short, and it doesn't even make contact. You've got 2 little scrap pieces of copper, sort of kind of placed nearby the standoff that brings that phase out to the motor. Come on, guys, really, this is not even atrocious. It's awful. You know, just good grief. You know, how much can you cheap this thing out? But then again, that's KO. They cut corners every chance they get. This is just awful. And here's the next phase. This is exactly the same thing that I showed on Facebook. You know, look at this. The copper is just little scrap pieces. It doesn't even touch. It doesn't even encircle the entire standoff. It's not soldered to it except for in that one little spot right there to the actual standoff. Yeah, this is really cheap. It's totally bodged together. And then you come down here, and you've got this little corner that contacts between copper to copper. Otherwise, you're totally dependent on solder to do all of the current carrying. This is awful. Terrible. Really, really not very good. Okay, I gotta flip the controller board around so we can see this last one. And you can see the same thing there. Oh, come on, camera, focus. Yeah. You get this little scrap piece of copper. There we go. Got this little scrap piece of copper. You know, what was that? Like, you know, they just like have a bin full of extra little bits, and they just said, "Oh yeah, let's stick one down there." And yeah, again, that one kind of touches, but yeah, this entire brass standoff ought to be encircled by copper, and well, it doesn't. Instead, you know, like you got this, a total gap. Yeah, there's no way that stuff works at 800 phase amps. It's just not even possible. It is going to get very, very hot. It's going to be a current choke point, and yeah, it's going to just be bad in every possible way. I cannot say that I am disappointed in KO enough, because, yeah, they lie to you, they misrepresent, they present false information, they claim things are good when they're bad, they refuse to acknowledge actual design flaws, and instead they attack the messenger rather than dealing with the fact that their controller has got significant design issues. Yeah, everything about this says to me, you should avoid. Yeah, not a great design. Not a great design. Well, I hope that helps some folks out. Definitely been an enjoyable exploration of a controller I've never seen before in life, and that my only vested interest in the whole thing is that, yeah, I just looked it up and found some really shoddy work and had KO attack me for it.